Hi guys, welcome to your Unit 3, Lesson 4 notes on the percent equation. Wow, very exciting. Last time we talked about the percent proportion. Today we're going to talk about the percent equation, which, spoiler alert, is the same thing as the percent proportion. You remember we had is over of equals percent over 100. This time all we're doing is we're solving for our is. So we'll be saying that is equal to our percent times our of number, and that's it. That's what this is all going to be about. So yay, ta-da! By the end of the day, there's the lesson. Okay, just kidding. By the end of the day, you'll be able to solve problems using the percent proportion. By using the percent proportion. That's grammatically correct. Okay, let's get started. Let's go. The percentage is always our is number. I believe, did we make that pink? Well, it's going to be pink now. Actually, let's make it orange. So our is our percentage, right? And we're going to, instead of saying is, we're going to say P for percentage. That's its technical name, but it's always is the is number in our sentence. And this time, instead of just using our percentage, we're gonna express our percent, our rate, as a decimal. So it's important to remember that our percent will be in decimal form, and then we'll have our base. Our base, last time we called that our of number. So in a nutshell, times the base. We have the rate times the base is our percentage. So we say that that's the same thing as P equals R times B. Basically, it's our, it's the wrong color. It's our percent out of 100 times our of number equals our is number. So what does this mean? If we're asked to find 4% of 160, well, we want to know what number is 4% of 160. So let's use our percent equation. So we'll say that P equals 4% is the same thing as 0.04 times 160. Again, P is our percentage number. We don't know what that is. We want to find it. 0.04 is our rate. That's the thing with the percent sign expressed as a decimal. And finally, our base, our of number. And then what is 0.04 times 160? That's 6.4. So 4% of 160 is 6.4. But if you want to write that in a complete sentence, you could say 4% of 160 is 6.4. Ta-da! There. Let's do another one. This time, we know our percentage. We know what our is number is. It's 12. And we know our rate. Our rate is 60%, but we're trying to find our base. We don't know what our of number is. So let's plug them in. We say that 12 is 60% is the same thing as 0.6 of some number we don't know what it is. Let's call it B. Of what number? Who knows? But that's 60% of that number is 12. Okay, so now let's solve this equation. We want to divide both sides by 0.6. 12 divided by 0.6 is 20. And then our 0.6's cancel out, and we're left with just B. Therefore, 12 is 60% of 20. Yay! We did it. Straight up, guys, if this is confusing to you, and whenever you will have a problem like this and you want to do your is over of equals percent over 100, I'm totally fine with that. That's how I solve things to this day. So this is great. The percent equation, though, is really nice when you have word problems. So we're going to do 3 examples of word problems today, and the percent equation will probably be easier than setting up a proportion. So, FICA, I think that's what that is. Well, anyway, this act says that you have to deduct 6.2% of your paycheck for Social Security. So let's say that you earn $140 in a week. You need to find out how much of that, like how much is 6.2 of that? What amount would be deducted from your pay each week? So we need to find out, okay, using our percent equation, we know our rate. We're taxed at a rate of 6.2%, and we know our base. We know that's $140. So we need to find out what is our percentage. So we have 6.2% is the same thing as 0.062. We know our base is 140. We calculate that out, and that gives us 8.68. So $8.68 would be deducted. So even though you're earning $140 this week, you would expect to get $131.32 on your paycheck because some of it went to Social Security. So there you go. Okay, so we do this for taxes. We can also use it for interest. I just gave away the next blank. So interest is the amount of money paid or earned on anything, right? So if you have some examples where you would find interest besides math class, because we always are interested in what we're learning. If you have a savings account, you can earn interest on that because the bank is basically paying you money for letting them borrow your money. So interest. You earn interest in a savings account. However, if you take out a house loan, you will need to, so basically any kind of loan, you will need to pay interest. So if you take out like $100,000 for a house loan, that's pretty expensive, then you would eventually pay back more than $100,000. What's probably coming up more relevant to you is not a house loan, but rather a student loan. If you go to college, you'll need to take out student loans. You will pay interest on those, and even maybe more pertinence to you, what's coming up even sooner might be a credit card. When you make credit card payments, you will also pay interest on those. This is why a lot of people go into credit card debt, because they don't take that into account, no pun intended. Okay, so let's calculate some interest here. I have a simple interest formula. There's also compounded interest. We'll get to that later. So basically super simple. You use this formula. And it's really pretty. It's pretty. Or you pay your part. I equals PRT. Here I stands for interest. So the interest that you owe or the interest that you earn. P represents the principal with a PAL. Principal. That means the starting moment, the starting amount that you invest or what you borrow at the beginning. And R is the rate, the annual interest rate. And finally, T represents the time. T is almost always time. The time that you're borrowing money from. Okay, so again, I is the amount of interest that you will pay. P is your principal. We'll use green because it's the same concept as the base. R is the same concept as your percent, your rate. Oh, I'm not highlighting these. My bad. And then finally, T is the time that you're borrowing this money for. Okay, so now we've got Miss Mariah, and she has a savings account. Good job. That will earn 4% annual interest. That's pretty fair. I've seen a lot lower, so good job. She wants to earn at least $50 in interest after 2 years. So how much money should she invest to earn $50 in 2 years? Well, let's borrow our formula right here. Let's plug in what we know. We know she wants $50 in interest. We don't know what her principal is. We're trying to find out how much should she invest at the beginning. We know her rate is 4%, and we know that her time is 2 years. Now look at this percent. This percent needs to be written as a decimal. So 4% is the same thing as 0.04. So the rest is the same. We're going to plug all this through our formula and see what we get. Okay, so 0.04 times 2, we can do that as our first step, is times 0.08. So we get 50 equals P times 0.08. Let's divide both sides by 0.08. And we get 625 equals P. So Mariah needs to deposit $625. The good news is, if she doesn't have that, she can start with whatever she has, and she'll keep earning interest. So you guys don't have to wait for a minimum amount. You should deposit things right away because you'll earn money on it. So that's an interesting problem. For our last problem, we have a mixture problem. A mixture problem is what you need to calculate when you have a mixture. Oh dear. I don't know what's up with my spelling today, guys. So mixture problems are what happens when you mix things. Great, right? When you combine 2 or more parts into a whole part. The parts that are combined usually have a different price of something, or maybe they'll have a different percent of something. A classic mixture problem that you guys actually experience every day without noticing it is grades. In my classes, and in several of your classes, if you have weighted categories, like if your tests are worth 40% or something, if you have weighted categories, this is a mixture problem. So that's really fun. Ask me in class if you want to know more. Okay, so let's say that Will is selling tickets to the fall play, and that adult tickets cost $8 and student tickets cost $5. We also know that he sold 35 more student tickets than adult tickets, and that he collected a total of $1,475. So how many of each type of ticket did he sell? Well, let's find out. Let's come up with a variable for the amount of tickets that he sold for the adult tickets. Say A for adult. Okay. So A is the number of adult tickets that Will sold. So the number of student tickets, if he sold, orange. If he sold 35 more student tickets than adult tickets, the number of student tickets he bought is 35 plus A, because he sold 35 more than adult tickets. Isn't that great? Okay, so what do we know? Okay, how many adult tickets did he sell? He sold A, whatever that is. How many student tickets did he sell? He sold 35 plus A. What is the price of adult tickets? Up here, they're $8. And what is the price of student tickets? They're $5. So, how much did he earn? And what are the sales there? The sales is always going to be the price times the number that you sold. Right? So the sales earned from adult tickets would be their price, which is 8 times the number sold. So 8A. Yay! Okay. But the price of the student tickets, the sales rather of the student tickets, is 5 times the number of student tickets sold, which is 35 plus A. Ooh. Okay, now let's find out what our total is. So to find out what our total sales are, we read the question and it says he collected a total, green for money, a total of $14.75. So we can put our total sales here, right where it says total sales. He sold a total of $13 and not $13.75. $13.75. Was it $13.75 or $14.75? I wrote this problem. $1,475. Okay. We also know his sales from his adult tickets. It's 8A. Whatever A turns out to be. But adult tickets is 8A. And the student tickets, we have an expression for that, is 5 times 35 plus A. So we know that when we take the sales of adult tickets and we add it to the sales of student tickets, if we add them together, that's going to be equal to our total sales. Great, we have our equation. Now let's solve for A. I'm going to rewrite this real quick as 8A plus 5 times 35 plus A equals 1475. Now that it's all neat and in one spot, let's go ahead and solve it. My first step will always be to distribute 5 to 35 and to the A, and that gives us, okay, we have A plus 5 times 35 is 175, plus 5 times A is 5A equals 1475. Now I'm going to rearrange these two guys because that allows me to add, to combine like terms. So we have plus 5A plus 175 equals 1475. Again, I just took these two and I switched them around. Now I have two like terms. I can combine my 8A and my 5A. 8A plus 5A is 13A plus 175 equals 1475. And remember, we're trying to get A all by itself, so we subtract 175 from both sides. Oh, you guys, this is going to be so great. 13A equals 1300. So to get A all by itself, we divide by 13, and A is 100. Isn't that super? So did he sell 100 tickets? No. Remember what A was? A, go all the way back up here. A is the number of adult tickets. And we need to find how many of each type did he sell. Okay, so he sold 100 adult tickets. But how many student tickets did he sell? Well, remember the number of student tickets is 35 plus A. And 35 plus 100 is 135. So that's 135 student tickets. Good job, Will. You must have been a great salesman. Okay, there we have it. Have a fantastic time on your homework. Remember to use the percent equation or this guy, but percent equation. Great fun. See ya.